In section 3.15, we're going to shift gears here, and we'll get into the new topic here of heat and temperature. Both very important considerations when we're talking about electric machines. And he tells us in this section that when we supply heat to a body, we're providing thermal energy to that body. And when that occurs, two things happen. First, there's atoms in the body that's being heated vibrate more, and the result of that is an increase in the temperature. So let's look at the effects of this and talk about that sort of in context of electrical machines. So, like I said, the heat applied imparts thermal energy to whatever it is that we're applying the heat. Vibrations increase, temperature increases. And so what we need to do, and we can quantify this, and it's outside, a little bit outside the realm of the electrical guy, but it's still a very important topic to consider when we're talking about electrical machines. So one little quick digression, one of the biggest problems that causes motor failure is not accounting for the heat and temperature within that motor. We always think about loads, but see, with associated loads increases is this associated temperature increase. And with the associated temperature increase comes the damage to the internals of a particular electrical machine. But he says, getting back to his topic, he says, for a given amount of heat, the increase in temperature depends upon two things. One, the mass of the body, and the second, what material it's made of. And we'll see there's an appendix in this textbook that gives something called the specific heat of certain materials. And we'll need to know that in doing some of the calculations that we do. He gives us an example, says if we were to supply 100 kilojoules of heat energy to a kilogram of water, the temperature would rise by 24 degrees Celsius. If we supplied that same amount of heat of 100 kilojoules to a kilogram of copper, its temperature would rise by 263 degrees centigrade. So you can see there's a huge variation between the temperature rise and the type of material. So, we need to make sure that we understand that, and that goes hand in hand with the design and composition of electrical machines and materials that are used. And then the last thing in this little section is this, if you remove heat from a body, its temperature falls. However, there is a lower limit to which you cannot fall any lower, and that is called absolute zero. And it corresponds to a temperature of minus 273.15 degrees Celsius or 0 degrees Kelvin. Now, again, SI units, we use Kelvin, but in reality and in normal functioning, we're using centigrade or Fahrenheit, so we're normally making those conversions. And he goes on to say, at absolute zero, all atomic vibrations cease, and the only motion that subsists is that of orbiting electrons.